Task number 3, uses for hashing. This task is part of the Hashing Crypto 101 module, which is part of the complete beginner path on TryHackMe. What can you do with hashing? Hashing is used for two main purposes in cybersecurity. To verify integrity of data, more on that later, or to verify passwords. Basically, in a really simple terms, even though later we read more about this subject, data stored can be accessed if it's matching the hash. And password, basically the same thing, verifying passwords. Hashing for password verification. Most web apps need to verify a user's password at some point. Usually when you log in, storing these passwords in plain text would be bad. You've probably seen news stories about companies that have had their databases leaked. Knowing some people, they use the same password for everything, including their banking. So leaking this would be really bad. Quite a few data breaches have leaked plain text passwords. You're probably familiar with rockyou.txt on Kali as a password word list. This came from a company that made widgets for MySpace. They stored their passwords in plain text and the company had a data breach. The TXT file contains over 14 million passwords, although some are unlikely to have been user passwords. Sort by length if you want to see what I mean. So basically the rockyou.txt that we have stored inside our, let's open a new tab. Actually, let's list inside user share word lists. Here you can see rockyou.txt. This is the file that is from the leaked breach of MySpace, right? 14 million. If we say, for instance, word count, 14,344,392. Adobe had a notable data breach that was slightly different. These passwords were encrypted rather than hashed, and the encryption that was used was not secure. This meant that the plain text could be relatively quickly retrieved. If you want to read more about this data breach, this post from Soapos is excellent. You can see it right over here. LinkedIn also had data breach. LinkedIn used SHA-1, which is a weak encryption algorithm for password verification, which is quite quick to compute using GPUs. You can't encrypt the passwords as the key has to be stored somewhere. If someone gets the key, they can just decrypt the password. This is where hashing comes in. What if instead of storing the password, you just store the password, the hash of the password? This meant you never have to store the user password, and if your database was leaked, then an attacker would have to crack each password to find out what the password was. This sounds fairly useful. There's just one problem with this. What if two users have the same password? As a hash function will always turn the same input into the same output. You will store the same password hash for each user. That means if someone cracks that hash, they get into more than one account. It also means that someone can create a rainbow table to break the hashes. A rainbow table is a lookup table of hashes to plain text. So you can quickly find out what password a user had just from the hash. A rainbow table trades time taken to crack a hash to hard disk space, but they do take time to create. Here's a quick example of, so you can try and understand what they're like. And here is the hash and here is the password, right? And they just check and match. Websites like CrackStation internally uses huge rainbow tables to provide fast password cracking for hashes without salt. Doing a lookup in a sorted list of hashes in reality is really quite fast, much faster than trying to crack the hash. Protecting against tables. To protect against rainbow tables, we add a salt to the password. I wanted to The salt is randomly generated and stored in the database, unique to each user. In theory, you could use the same alt for all users, but that means that duplicate password will still have the same hash. And the rainbow table could still be created specific passwords with that salt. The salt is added to either the start or the end of the password before it's hashed. And this means that every user will have a different password hash. Because hashes can be the same, salting them makes them unique, even if they have the same password. Hash functions like bcrypt and SHA-512crypt handle this automatically. Salts don't need to keep private. Let's jump inside CrackStation. And actually we'll add this to our bookmark. Add it over here. All right. Now, answer the questions below. Crack the hash. We have the following hash. Using the rainbow table manually. Basketball. Crack the hash using online tools. Okay, we have also to verify. Crack this hash. Let's see what we get. Okay, so we get nothing. Okay, cool. You can see it over here from this one, hashes.com. This is the meaning of the hash. This is behind the hash and possible algorithms, MD5, and then by probability. This one being the most probable and going lowering the chances of the algorithm type. Should you encrypt passwords? Yes. Encrypt? No. It's nay. You should hash passwords.